Sometimes we want to estimate a population mean from sample data. We can create a confidence interval estimate of the mean. The confidence interval is used to estimate a population mean with a certain level of confidence. The interval is computed using the formula x bar minus z sub alpha over 2 times sigma over square root of n is less than mu is less than x bar plus z sub alpha over 2 times sigma over square root of n. In this equation, x bar is the sample mean, sigma is the population standard deviation, n is the sample size, alpha is the significance level, which is equal to 1 minus the confidence level, and z sub alpha over 2 is the z-score associated with the confidence level from the standard normal distribution. Let's look at an example of constructing and interpreting a confidence interval. A home goods store sells potting soil in 10-pound bags. From a sample of 25 bags, the average weight is found to be 10.2 pounds with a standard deviation of 0.4 pounds. What is the 95% confidence interval estimate for the mean weight of all 10-pound bags of potting soil? From the problem, we can determine that the sample size n equals 25. The sample mean x bar is equal to 10.2 and the standard deviation is 0.4 pounds and alpha equals 1 minus 0.95, which equals 0.05. A table of probabilities for the standard normal distribution shows that the z-score that corresponds to the probability alpha over 2 is 1.96. Now we have all the values needed to calculate the confidence interval. We begin with the original equation for finding the confidence interval. Substitute the values to get 10.2 minus 1.96 times 0.4 over the square root of 25 is less than mu is less than 10.2 plus 1.96 times 0.4 over the square root of 25. Simplifying gives us 10.2 minus 1.96 times 0.08 is less than mu is less than 10.2 plus 1.96 times 0.08. Multiply to get 10.2 minus 0.1568 is less than mu is less than 10.2 plus 0.1568. Finally, subtract and add, rounding to 2 decimal places, to get 10.04 is less than mu is less than 10.36. What does this mean? It means that we are 95% confident that the interval from 10.04 to 10.36 contains the true mean weight of all 10-pound bags of potting soil. What can we say about the other 5% where the interval does not contain the true mean weight? In the normal distribution, the remaining 5% of the data is divided into 2 pieces, with 2.5% of the data before the interval and another 2.5% of the data after the interval. In this example, there is a 2.5% chance that the true mean is less than 10.04, and a 2.5% chance that the true mean is greater than 10.36.